September. Hello everyone, my name is Nandini and I work at the National Autonomous University of Mexico. Today we will be presenting some data on the demography of Hexarthra jenkinae. We isolated 2 strains of this rotifer from an ephemeral and one from a permanent habitat in Lake Texcoco. A short introduction. Lake Texcoco was once part of a very large water body that covered the Valley of Mexico. It covered an area of almost 1,500 square kilometers and reached its peak development around 11,000 years ago. One of the few soda lakes in Central and South America is Lake Texcoco. It is made up of 5 different lakes, Zumpango, Xaltoca, and Texcoco, which are saline, Lake Xochimilco and Lake Chalco, which are freshwater systems. Spirulina was harvested from Lake Texcoco and consumed even at the time of the Aztecs. And unfortunately, in the 1960s, when the lake almost went dry, in order to restore it, they decided to fill it with partially treated wastewater. So Lake Texcoco basin has permanent and ephemeral water bodies around it. Lake Naborcarillo is a permanent lake in the system, and it is surrounded by several shallow pools which become turbid and fill during the rains. But for many months of the year, close to 6 to 8 months, these pools are completely dry. The phytoplankton is dominated by cyanobacteria, particularly Planktothrix, Spirulina, and Microcystis. The dominant zooplankton in this system are Brachionus dimidiatus, Brachionus caliciflorus, Asplankna sylvestre, Moina micruda is a very small cladozoan, and the copepod Acanthocyclops Conferratum americanus, because it tolerates extremely high salinities in the system. In spite of the dominance of the toxic cyanobacteria, the system is highly productive, and this is common for many soda lakes around the world. They are one of the most productive ecosystems. Brachionus dimidiatus, which is found in this lake, is rarely found in other freshwater bodies in Mexico City. The pools and the lake are dominated by Brachionus dimidiatus and Hexarthra jenkinae. Hexarthra is a small rotifer which has been reported from soda lakes in Europe and Africa. Ephemeral waters are common throughout the world in tropical systems as well in polar conditions. In polar conditions in the Arctic and the Antarctic, water freezes during the winter months, but in the summers it tends to melt and form shallow ephemeral pools. In tropical systems, rains fill up shallow water bodies and form these pools. Rotifers are amongst the most common metazoans in these systems since they have a very short life cycle. You can see over here, Brachionus variabilis has a lifespan of about 17 days. Rotifers normally live between 5 to 30 days and they produce resting eggs. These resting eggs are very important for them to tide over these unfavorable dry periods so that when water appears in the system again, they hatch. So we found Hexarthra jenkinae in the lake as well as in the pools around it, and we wondered whether the demographic characteristics of both strains, those from the lake and those from the pool, are similar or different. We tested this by comparing the population growth rate and life table demography of both the strains at 2 different food levels of the alga Nanochloropsis oculata and at 3 salinities, 10, 12.5 and 15 grams per liter. A quick look at the methods. To begin with, let me introduce to you Jose Alberto Carmona Ruiz, the student who conducted this study for his master's program. He is now working on computers. He isolated 2 strains of Hexarthra jenkinae from Lake Naborcarillo and from the Texcoco pools. We fed these organisms using Nanochloropsis oculata at 2 different densities, 250,000 cells and 1 million cells. And at 3 different salinities, we conducted the population growth and life table demography experiments. The salinities we tested were 10, 12.5 and 15 grams per liter. The experimental design was simple. We tested the population growth using both the strains at 3 test salinities and 2 food levels, setting up 4 replicates per treatment. The life table demography experiments have followed the same pattern. We began the experiments of population growth using 10 individuals in 20 ml of medium, and the life table experiments using 10 neonates less than 3 hours old in 20 ml of the medium. Population growth studies were counted once in a day and the medium was changed. For the life table experiments, we observed them twice a day, separated the neonates and passed the adults to the fresh medium once a day. Experiments continued for 28 days or so in the population growth experiments until the populations began to decline. The life table experiments did not last so long. The lifespan of these rotifers was close to 10 days. We estimated different variables, population growth rate, maximum population density and egg ratios from the growth experiments. And based on the demography experiments, we observed the survivorship and fecundity. And based on those values, we calculated the average lifespan, life expectancy at birth, gross and net reproductive rates, generation time and population growth rate. We thought that based on these characteristics, we could compare the 2 strains. Now look at the results. You can see from the population growth experiments that with greater food availability, the populations grow better. Okay, this follows common logic. But with increasing salinities, the populations survive, but the numbers tend to decline. Peak densities were observed at 10 grams per liter of salinity, and this was lower, the peak density was lower in the strain from the Lake Naborcarillo, and it was higher in the strain from Texcoco. The differences are significant. They reach densities less than 1,200 individuals, and the lake from the pool and the rotifers pattern from the pool reach densities of around 1,500 individuals. The population growth rate decreased with increasing salinity, as you can see over here, and the effect of food was there, but it was not very clear. With increasing food availability, the differences are significant, but mostly in the strain from the pool. The same is true for the maximum density. The strain from Naborcarillo reached lower peak densities, and the effects of salinity were clear, but in the strain from the pool, the density that was reached was higher at 10 grams per liter, and in both cases they reached fairly high densities at higher salinities and at higher food availability. The lake strain had lower growth rates than the pool strain. The lake strain had growth rates of 0.12 to 0.41 per day. The pool strain reached peak growth rates of 0.52 to 5 per day. There were significant differences in all these variables. The survivorship, on the other hand, did not show significant differences with regard to food availability. With regard to salinity, the differences were clear. With increasing salinity, survivorship decreased. And greater food availability helped offset this outcome only in the case of the strain from the pool, where greater food availability resulted in a better survivorship at 10 grams per liter. Fecundity also decreased with increasing salinity, but increased with increasing food availability, and the fecundity of the strain from the pool was higher than that from the lake. Now, under conditions of dryness, salinity increases, and with this increase in salinity, it is clear from our study that there is a decrease in all the demographic variables. Therefore, this is a stress for the organism. Food levels tend to offset this adverse effect of salinity only in the case of reproduction, and that too at low salinities. At higher salinities, there is little effect of greater food availability. And at extremely high salinities of 15 grams per liter, Hexarthra jenkinae showed negative growth rates based on the demographic experiments. We also observed that more myctic eggs were being produced in the experimental containers at 15 grams per liter. In the case of the strain from the pool, they were able to withstand salinities better than the strain from the lake. They also tend to grow and reproduce more with greater food availability, regardless of the slightly higher salinity here. But in both cases, the best results were observed at 10 grams per liter. The egg ratio, which is a very sensitive indicator of stress in rotifers, also showed that rotifers from Naborkaryo Lake were subject to greater stress with increasing salinity, and this was much more at lower food levels. By reaching a density of around 200 individuals in total, the egg production had declined. On the other hand, the strain from the pool at the same condition of food and salinity reached densities of around 600 individuals, and still they were reproducing and producing eggs. The adverse effect of salinity was offset to some extent by greater food availability in both the cases. However, this clearly shows that the strain from Naborkaryo was more sensitive to salinity than the strain from the pool. And coming to the conclusions, we conducted a study on Hexarthra jenkinae almost 20 years ago, but in that case, we had observed, we got the rotifers from Lake Alchichica, which is also a saline lake in the center of Mexico, in the state of Puebla. This strain reached densities of 150 to 200 individuals per milliliter under laboratory conditions at a salinity of 12 grams per liter. In our experiments, at more or less this salinity of about 12 grams per liter, the strain from Naborkaryo reached densities of 10 to 30 individuals, whereas the strain from the pools around Texcoco reached 40 to 70 individuals per milliliter. It is quite possible that these three strains represent different cryptic species. Perhaps Hexarthra jenkinae is a species complex, and this needs to be tested using molecular tools. Finally, we observed that the strain from the lake had lower growth rates than the strain from the pool. It is important in nature for ephemeral strains to rapidly utilize the available resources, and perhaps that is the reason why the strain from the pool had much higher growth rates. There was also a greater tolerance of the pool strain to salinity, which is similar to conditions to which they are subject to in nature. Hexarthra jenkinae tolerated salinities from 10 to 15 grams per liter. This has been reported also from studies in saline lakes in Mexico and Africa. Brain reported in an analysis of saline water bodies, soda lakes in Africa, that after 18 grams per liter, it is not possible to find Hexarthra in those systems. And we observed significant differences in the life history strategies of Hexarthra jenkinae, depending upon whether they were isolated from the pool or from the permanent lake. Needs to be seen whether they are the same species or part of a species complex. Thank you very much for your attention.